Hello, good evening, everyone, and welcome back to another session in this subject of fluid mechanics. I welcome you all to this session on Reynolds and Froude model law. This topic of fluid mechanics is also very important for the GATE 2021 exam. Hi, Naveen, very good evening. Hi, Shamitra, very good evening. Welcome to the session. Hi, Dinesh Kumar, good evening. Welcome to this session on Reynolds and Froude model law. Now, from this topic also, you can expect a lot of questions in the GATE exam. So everyone quickly join me for this session. Hi, A to Z. Okay. Yeah, very good evening to everyone and welcome to this session. So today in this session, we'll be studying about the concept of Reynolds and Froude model law. What is the importance of this model law? Why we use this model law? Okay. So that is a very important topic for GATE exam. Hi, Ajit Kumar. Good evening. Hi, COT Gaming. Good evening. Hi, Rishabh Yadav. Good evening. So good evening, everyone, and welcome to this session. The last topic that we have covered was viscous flow through pipe, and that topic basically today dimensional analysis. Yeah, that is a part of dimensional analysis. In the topic of dimensional analysis, will be studying the topic of Reynolds and Froude model law, which is a very important topic of the subject of fluid mechanics, because you can expect a good quality question from this topic. Will there be any session on potential flow vorticity? Hi Ratnu Sanupal. They will be right now. We have not planned any session for this potential flow and vorticity, but we can plan it in the future. Definitely, we can plan for it. Okay. Hi Vishnu Vardhan Reddy. Very good evening, Rishabh. Yeah, definitely tomorrow we'll be revising the topic of boundary layer. Tomorrow we'll cover the topic of boundary layer also. So good evening to all of you and welcome to this session. Everyone quickly join me for the session. Those who have joined me already, please like the session and also share the session. Now we have got many less students in the session. Very few students have joined this session. So good evening all of you and welcome to this session on Reynolds and Froude model law. Basically this topic is a part of this topic belongs to basically dimensional analysis topic of fluid mechanics. So here I will be telling you about these two model law. We'll be solving around 7 to 8 questions. Okay. So everyone quickly join me. Hi Kushwaha, AK Kushwaha, Ankur Kumar, good evening. Welcome to the session. Very good evening to all of you. So my dear students, those who have already joined me for this session, please give some time to like the session and share the session also. And if you have not subscribed our channel, then please do subscribe our channel also. Okay, so shall we begin? Shall we start the session? Tell me everyone, should we start the session? Should we start the session of Reynolds and Froude model law? So there will be some relations that I will be telling you. This Reynolds and Froude model law, it is very, very important. When we'll be solving numerical on this topic. Akash will be solving the numericals in the same class only. Okay. In these classes, whatever topics we basically take in these classes, I will will be solving a numericals also side by side. Okay. Not only will be studying the theory, will be also solving the numericals. Okay. So let's begin the session. I would like to start with my introduction first. I'm Vikas Sir. I have 5+ year teaching experience. I did my MTech in thermal engineering from Thapar University, and I have mentored more than 10,000 plus aspirants for different exams like GATE, Engineering Services, and SSC. My area of expertise includes subjects of fluid mechanics, thermal and applied, and heat transfer subject. Okay, so let's begin this topic of Reynolds and Froude model law. In order to understand this topic, my dear students, let me just brief you about a very important thing. What is the meaning of why we require this Reynolds and Froude model law? What is the need of this model law? What is the need of this model law? So basically, this can be asked in your interview of some public sectors if you get selected in the GATE exam. What is the need or requirement of this model law? Why we need them? See, the simple need, or we can say the simple reason why we use this model law is, as you know that if we have to make a prototype, or if we have to make a submarine, or if we have to design a submarine, you cannot directly make an actual submarine, right? Firstly, you will making a model of that, right? So basically, when you have to, if we have to do some experiments for conducting, if you have to design a prototype, before design of a product like submarine, dams, spillway, we conduct some aeroplanes, we conduct some test on test, or we can say test or experiments, on the model. What is a model? You all have done your BTech, you must have completed your BTech, and in your BTech also you must have made some final year model. So what is the meaning of that model? Model may be a working, it is a basically, it exactly looks like a prototype or original product, but it is small in size. Okay, it is not actually a bigger. For example, if we are making a model of a turbine, okay, or if you have made model of a submarine or aeroplane, it is just a model, it is not the actual product. Okay, so model is the, what is the meaning of model? It is a replica of, replica means it is duplicate, it is replica or duplicate of original product. And what is the meaning of original product? The original product is also called as prototype. Prototype is the original working product, that is called prototype. Okay, so when we have to design something like a submarine, or we have to design an aeroplane, or we have to design a dam or something like that, we have to firstly make a model of that, we have to run some test over that model, and after getting satisfactory results, we make our actual product, which is also called prototype. Okay, so that is why we use this model law. Now, what is the significance of Reynolds model law and Froude model law? Why we use them? So main significance is that, as you know that Reynolds model law is related to, in Reynolds model law, we compare the Reynolds number of model and prototype. We compare the Reynolds number of the model and prototype, and by doing the comparison, basically we can get the, for example, if you know the value of velocity of the model, you can also find the velocity of the prototype by comparing the Reynolds model law. Okay, similarly, if you can use the Froude's model law also. But why when will be using the Reynolds model law, when will be using the Froude model law? In what application will be using these model law? What are the application of these? So the application of this model law are different. Reynolds model law will be used in the pipe flow and fully immersed flow, fully submerged flow. In fully submerged application like submarine and pipe flow and internal flow will be using the Reynolds model law. Froude model law will be used for study of spillway, notches, flow over a plate. In this application, we'll be using a Froude model law. Okay, so depending on what application basically are given in the exam. Okay, if the application is related to the study of pipe flow, okay, then we have to use Reynolds model law. If the application is spillway, notches, wear, flow over a flat plate, okay, that will be Froude model law, which will be used in that situation. Okay. Now these model law are based on a particular number. For example, Reynolds model law is based on Reynolds number. Reynolds model law is based on Reynolds number, and Froude model law is based on Froude number. So what are these numbers? Reynolds number and Froude number. What are these numbers? See, these numbers are called as dimensionless numbers. Okay, these are the dimensionless numbers which have no dimensions, and they are basically formed by some forces. What are those forces? Let us understand those forces. So types of forces. In Reynolds and Froude model law or Froude number, what are the types of forces we consider in the Reynolds and Froude number? First force we are going to study is inertia force. What is inertia force? Inertia force is basically, you know that Newton gave the law of motion, but before law of motion, before he gave the Newton's second law of motion, he gave the Newton's first law of motion, which is called law of inertia. Inertia is basically the opposition to a particular state of rest or state of motion. That is called inertia force. So inertia force, if the body is moving, suppose a body is moving with a particular acceleration. So inertia force, it is the opposite force. It is a force acting in opposite direction of applied force, and its value is equal to mass into acceleration. That is equal to inertia force. Now mass is equal to what? We know that density is equal to mass per unit volume. So mass will be equal to density into volume. So we can also write it as density into volume into acceleration. What is acceleration? A. Acceleration is equal to dv by dt. It is equal to dv by dt, right? So we can write it as dv by dt. Now this is volume here. Why I have to tell you very important thing here. See, every unit, every physical quantity has got a unit and dimension. Every physical quantity has got a unit and dimensions. For example, mass has the unit of kg and dimension of, what is the dimension? M. Length has the unit of meter and the dimension of L. Time has got the unit of second and the dimension of t. Similarly, velocity has got the unit of meter per second and the dimension of liter, lt minus 1. Similarly, area has got the unit of meter square, but you can also write it in terms of L square. Volume has got the unit of meter cube, but you can write it as L cube, because volume is basically it is the cube of basically it is also a scalar quantity, okay, geometric quantity. So it will be, area will be having dimension of L square, volume will be having dimension of L cube. Okay, so this is how you'll be writing the dimensions of a particular quantity. So we can write, because it is density, it is volume, so you can write it as rho into L cube. The dimension of volume will be L cube. Okay, into dv by dt. dv by dt is equal to this is acceleration. You can write it as dv by dt. Clear? So this we can write it as dv by dt. Now my dear students, if you clearly focus here, this is also can be written as rho into L square. Or rather than writing as dv by dt, we can also write it as v by t. Okay, v by t, acceleration. So you can also write as rho into L into v by t. This L by T will be equal to what? Length per unit time. It will be velocity. So inertia force will be equal to rho L square into V square. This will be inertia force. Inertia force. Another force we are going to discuss is viscous force. Viscous force. What is viscous force? You know that by Newton's law of viscosity, we know that tau is equal to mu du by dy. This is Newton's law of viscosity, right? Now this is the shear stress. You have to find the viscous force. Viscous force or shear force, that will be equal to, shear force per unit area is equal to mu du by dy. Okay, you can also write as mu into du is, you can write as V and dy is L. Okay, this is area, so it will be, shear force will be equal to mu into V by L into area. Area will be having dimension of L square. This will get cancelled out. So shear force will be equal to mu into V into L. Okay, so shear force of viscous force is equal to mu into V into L. And inertia force is equal to, inertia force we have got as rho into L square into V square. So what is Reynolds number, my dear? Reynolds number is defined as the ratio of inertia force over, it is defined as ratio of inertia force divided by viscous force. Okay, that is equal to rho into L square into V square divided by mu VL. This V will get cancelled out, this will get cancelled out, you will be getting as rho VL by mu. This is called as Reynolds number. Okay, Reynolds number is equal to rho VL by mu. Here L is called as, L is characteristic dimension. It depends on the type of object for which you have to find the Reynolds number, type of body. Okay, it is also called characteristic dimension. Now this characteristic dimension L will be equal to L for plate. For flat plate, it will be equal to L. This L will be equal to D, that is diameter of pipe. It will be diameter of pipe. In case of a pipe, it will be equal to diameter of the pipe, characteristic dimensions. Okay. In case of a flat plate, it will be L. Clear? So this is the Reynolds number. Now next number we have to study is Froude number. What is Froude number? How can you find the Froude number? See, Froude number is equal to ratio of inertia force divided by viscous force. Inertia force by gravity force, not viscous. Okay. I'm just checking that you guys are paying attention or not. So it is ratio of inertia force by gravity force. So what is gravity force? Gravity force will be equal to what? Gravity force is equal to, yeah, for pipe it will be L will be equal to D. Gravity force is equal to mass into acceleration due to gravity. Mass is equal to density into volume into G. Volume has got dimension of rho L cube. So this will be the gravity force. Gravity force will be equal to rho into L cube into G. If you put the value, inertia force was equal to rho L square into V square, and gravity force is equal to rho L cube into G. This will get cancelled out. This will get cancelled out. You will be getting as this as V by root L into G. Okay, this is the value of the Froude number. Okay. So I have just told you that what is the Froude number, what is the Reynolds number. So Reynolds number is the ratio of inertia force by gravity force. So Reynolds number is ratio of inertia force by viscous force, and Froude number is ratio of square root of inertia force by gravity force. Okay. Now in our Reynolds model law, we basically will be comparing our model and prototype. We'll be comparing the model and prototype based on the Reynolds number. So what is Reynolds model law? It says that the Reynolds number of model should be equal to Reynolds number of prototype. Okay. For conducting the model test, we'll be basically comparing the Reynolds number of model and prototype. So what is Reynolds number? It is rho into V into L by mu of the model is equal to rho into V into L by mu of prototype. Two things which are very important from the question which are asked in the exam. See, right now I am writing as rho VL by mu, but Reynolds number can also be written as rho VD by mu. Okay, whether you write Reynolds number as rho VL by mu or rho VD by mu, it doesn't matter because length and D, L and D are geometric property. So it doesn't matter whether you write L or D, especially for comparison of Reynolds model law. Okay, if you are writing rho VD by mu, then also it does not affect the answer. Okay, so you'll be getting Reynolds density of the model into velocity of the model into the characteristic dimension of model divided by mu of model is equal to density of the prototype into velocity of the prototype into length of the prototype divided by mu of the prototype. Okay, so what is the advantage of this Reynolds model law? What is the advantage and when do we use this Reynolds model law? See, the main advantage of this model law is sometimes, suppose you have to if we are studying the application of a submarine, okay, we have to basically make a submarine, let's say. So we cannot directly make a big submarine. We have to make some design projects. We'll be making a model of that. On that model of submarine, we'll be running some test. Okay. For example, we are testing a submarine in a wind tunnel. Okay. So when we'll be testing, the rho will be constant. No, the rho will not be constant. See, for example, see, what is the application of Reynolds model law? Reynolds model law application is application of Reynolds model law. Where do we use Reynolds model law? Reynolds model law is used in, pipe flow. It is used in pipe flow. Flow in fully submerged body, fully immersed body, like submarine or aeroplanes. Okay, so these are the applications where we will be using the Reynolds model law. For example, let me tell you a simple example. Let us say we have to make a submarine. So we cannot simply design our submarine. We cannot completely make an actual submarine. Before making the actual submarine, we have to make a model of that. Now that small model of submarine has to be tested somewhere. So where can we test that model of submarine? Okay. So suppose we have made a model of submarine. Let's say we are testing that model. We are testing it in a wind tunnel. Why we are testing that in a wind tunnel? Because in the wind tunnel also that model will be complete. See, the main idea of a submarine. What is the meaning of submarine? Submarine is a fully immersed body. So why will be testing the submarine in a wind tunnel? Because in the wind tunnel also this submarine model of the submarine will be completely immersed. The model of the submarine will be completely submerged in the air. It will be completely submerged in air. So although we are trying to test the submarine model in the wind tunnel, which will be having air as a fluid, not water. Okay. Then after that we will be applying the Reynolds model law. Rho VL by mu of the model is equal to rho of prototype into velocity of prototype into length of prototype divided by mu of prototype. So because we have tested our model of submarine in a wind tunnel will be having air. Now air will be having density of, air will be 1.25. Viscosity of air will be different than prototype because prototype is submarine. Submarine will be tested in water. Actual prototype will be some actual prototype of submarine will be tested where? That is actual prototype of submarine will be tested in, will work in water, right? It will work in water. It will be having density of the water, sea water will be 1025 kg per meter cube. That will be density of the water, sea water. The viscosity of the water will be different. It will be different. It will not be same here. Okay. So what we are trying to do here is, we have made a model of a submarine. We have conducted our test result of that model in a wind tunnel having different type of fluid. Whatever result we'll be getting for velocity, we'll understand, okay, that when this model of submarine is tested in a wind tunnel, we are getting this velocity or this length and something like that. If we try to do the same in a model, then what will happen? You can find the velocity of the prototype from here. Suppose you have to find the velocity of prototype, you can find it at density of the model by prototype into viscosity of the prototype by viscosity of the model into length of the model by length of the prototype into velocity of the model. Okay. So in this way we can find the velocity of prototype. If suppose you know the velocity of the model, you have found the velocity of your model in the wind tunnel. After testing it in wind tunnel, you have got the velocity. You know the value of scale ratio. So you can easily find the value of the velocity of prototype from this relation. Is it clear to everyone? So this is how we'll be using the Reynolds model law. Clear everyone? In the very similar manner, we'll be using the Froude model law. But Froude model law will be giving you different types of result. Okay. So Froude model law is basically used for free surface. Free surface means flow over a plate. Flow over a flat plate. It is used in a free surface, flow over a flat plate, spillways, notches, wears, sluices means gate. Gates in dam. Channels, flow through jet. In all these applications, we will be using this Froude model law. Okay, clear everyone? If you are having a doubt in thermodynamics, my dear, then you can ask that doubt in the comment box. Okay, Muhammad Hafzal. Okay. Let me just complete this topic. After that, you can ask your doubt. Okay. So in Froude model law, we'll be using this Froude model law in this application: flow through jet, flow through free surface, spillway, notches, wears, sluices, channels, flow through jet, and in all this application. See, Mohammed, I am not having any problem in giving answer to this question. But let me just complete this Froude model law. After that, I will take your query. Don't worry. Okay. So Froude model law of model. The Froude number of model will be taken as equal to Froude number of prototype. Here also same thing will be doing. What was Froude number? Froude number was equal to, this was Froude number. Okay, so you'll be basically equating the Froude number of model and Froude number of prototype. So you'll be getting as V by root L into G for the model is equal to V by root of L into G for the prototype. Clear everyone? Is it clear to everyone, my dear students? So when we will be applying the Froude model law in this application, we will be simply equating the model, Froude number of model and prototype. But what result we will be getting from here? The result that we will be getting from here will be very different. So this G will get cancelled out automatic. We will be getting that velocity of the model by velocity root of LM will be equal to Vp by velocity of prototype divided by root of LP. Okay, so from here we will be getting that Vp by Vm will be equal to root of LP by LM. This is what we will be getting from the Froude model. By applying the Froude model, we are getting that velocity of the prototype by velocity of model is equal to length ratio of the prototype by model, or length of the prototype over length of model, square root of that. What is the meaning of this LP by LM? What is this thing? This is also called as LP by LM, is also called as scale ratio of length. Although it is a scale ratio of length, but my dear, if they have given in the exam, if they have given, sometimes they will be using dp by dm, sometimes they will writing dp by dm. Even dp by dm will also be equal to lr, because diameter will also be having the unit of L, dimension of L. It is actually the dimension of L, length. Okay. So it will be having dimension. It is also called scale ratio of length. It is LP by LM. But in your exam, they will be giving you ln by LP. They will be giving you ln by LP equal to something like 1 by 20, like this. In your exam, they will be giving you the ratio, opposite ratio will be given to you. So you have to figure out that, always remember that, length of the prototype will always be greater than length of the model. Or we can say that prototype will be having bigger dimension. Prototype will be having bigger dimensions than model. Okay, clear everyone? Is it clear to all of you? मैकेनिकल मार्बल पे कौन सी क्लास हो रही है? ऑन मैकेनिकल मार्बल आई थिंक हीट ट्रांसफर क्लास इज गोइंग ऑन, और was going on. Okay. Hi Vikas Yadav, very good evening, welcome to your session. So always remember that prototype will be having higher dimension, bigger dimension than model. So if they have given you the scale ratio, that is 1 by 20, you have to figure out that this ratio is, inverse ratio is given. They have given the value of length of model by prototype, not prototype by length. Okay, so that is velocity of the prototype by velocity of the model is equal to LR. It is also called scale ratio of length. Okay, it is also called LR, stand for scale ratio of length, and this scale ratio of length is equal to LP by LM. Okay, it is equal to LP by LM. Clear? I am in second year. ME is turbo machinery, important. Hi Ratna Sanupal. It's good that you are in second year and you are preparing for GATE exam, but I think you are starting so early. That is very good. Turbo machinery, hydraulic turbines are important, but hydraulic pumps are not important. Only turbines are there in the syllabus of GATE exam, but pumps is not there in the syllabus. Clear everyone? So now, my dear student, let's focus on here that we have got that velocity of the prototype over velocity of the model is equal to velocity of the prototype over velocity of the model is equal to root of LP by LM. So this is the relation between the velocity of prototype and model for Froude number. According to Froude number, this is a relation. According to Froude law, this will be the relation. Okay. But now I am going to tell you the relation between the other for other quantities in the Froude model law. For time of the prototype by time of the model will be equal to root of scale ratio of the prototype by model. This is also called as time ratio. It is also called time ratio. Time ratio of prototype and model for Froude model law. This is all we are talking about, Froude model law. Okay, so time in the prototype by time and model will be equal to root of LP by LM. Okay, so LP by LM will be given you in the question. Acceleration of the prototype by acceleration in the model will be equal to 1. Acceleration of the prototype or acceleration of model will be equal to 1. Always remember that. The discharge of the prototype over discharge in the model according to Froude model law will be equal to LP by LM over 5 by 2, or it is equal to LP by LM. Yeah, it is a part. It is not just a part of dimensional analysis. It is actually the dimensional analysis which comes in the exam. Okay. Similarly, the force of the prototype over force of the model according to Froude number, where will be the application of Froude law. Force of the prototype or model will be equal to LP by LM Q. And power in the prototype, power in the model will be equal to LP by LM over 3.5. But these are only used for, these relations will only be used for Froude model law. Wherever Froude model law will be applied, these relations will be used. The relation of velocity of the model and prototype with respect to the scale ratio. Okay. The acceleration of the prototype or model with respect to scale ratio. Yes, you can contact me. I will tell you my contact, Mohammed. Okay, don't worry. So these relations are very, very important. If you want to have any doubt, you can ask me by using this mail ID vikas.bazoria@gradeup.co. Okay, you can, if you are having any doubt, you can ask me here. Clear? If you are having any doubt regarding anything, you can ask me here. You can just mail your query here, Mohammed, and I will definitely keep in touch with. I will reply to your question. Okay. If you are having if anyone is having any doubt, you can just ask me over here on this mail ID. This is my official mail ID from where you can contact me. Okay, clear everyone? So if you are having any doubt of any previous session, you can ask me on the mail ID. Okay. So my dear, this is relation that you have to remember. These are the relations you have to remember. This is the time ratio, power ratio of the prototype by model, acceleration ratio, velocity ratio, okay, discharge ratio, and force ratio. Clear everyone? Now let us solve few questions so that you will be having more idea. Now we'll be solving some questions based on this so that you can have more clarity of this concept. Okay, when we're solving the question, you will be having more clarity. So hurry up guys. A large ship is towed through the sea water at a speed of 8 meters per second. If the tests were conducted in a 1 by 80 scale ratio, then find the force required in meganewton to tow the ship if force required to tow the model is 8 Newton. So we are having a large ship which is moving at a speed of 8 meters per second. If the tests were conducted in a 1 by 80 scale ratio. Now firstly you have to identify that which model law will be applied. Is it Froude model law which will be applied or Reynolds model law which will be applied? Tell me. Which model law will be applied here? See, I forgot to tell you that Froude model law is also used for partially submerged bodies. For partially submerged bodies, we use the Froude model law. Okay, and for fully submerged body, we use the Reynolds model law. For fully submerged or immersed body, we use the Reynolds model law. Okay, and for partially submerged body, we use the Froude model law. So tell me what is the answer for this question. We are using the ship. We are studying the application of ship here. Ships comes under partially submerged body. It comes under partially submerged body. Because it comes under partially submerged body, we will be applying the Froude model law. We will be using the Froude model. Very good, excellent. So we will be using the Froude model law in this application. Okay. Now, in this question, as you know that you have to find the force. They have given the scale ratio. Scale ratio is 1 by 80. That means Lm by Lp is given as 1 by 80. Why I am saying Lm by Lp is given 1 by 80? Because I have always told you that length of prototype will always be greater than length of model. If they have given this as 1 by 80, something like that, it means they have given Lm by Lp. So Lp by Lm will be equal to 80. Okay. Akhilesh is getting 4.096, Vikas Yadav 4096 kilonewton. You have to find the force in meganewton, my dear. Okay, not in kilonewton. Yes, everybody try to answer the question quickly. You have to give the answer in meganewton, 4097 meganewton. So the answer will be, the force in the prototype will be 4.097 meganewton. This will be the value of the force. Akhilesh, your answer is correct. Okay, so simple the relation I have just told you, that force of prototype by model is equal to Lp by Lm cube. That will be equal to 80 cube. So force of the prototype by 8, because force in the model is 8 Newton into 80 cube. So you'll be getting force of prototype will be equal to 80 into cube into 8. Tell me what is the answer you are getting, please. So you'll be getting this value as 4096,000 Newton, or it will be equal to 4.096 meganewton. Are you getting this value, everyone? So you have to firstly understand which model law will be applied, because we are using here Froude model law. It is case of a partially submerged body. Next question, a geometrically similar hydraulic model of a spillway has been constructed on a scale of 1 by 16. If the prototype discharge is 2048 meter cube per second, what would be the discharge in the model? Hurry up, my dear students, hurry up, be quick. We are having a geometrically similar hydraulic model of a spillway. Now spillway comes under which application? Spillway comes under Froude model law. It comes under Froude model law. Because it comes under Froude model law, we will be applying the Froude model law for this. So what they have given here, the scale ratio is 1 by 16. Yes, hurry up, be quick. I will be giving you 1 minute for solving this problem. Don't worry. Yes. So we are having a scale ratio of 1 by 16. Always remember that the scale ratio of 1 by 16 simply means that they are giving you the ratio of length of model by prototype. Okay. If it is 1 by 16, that means they are giving you Lm by Lp. Lm by Lp is equal to 1 by 16. So Lp by Lm will be equal to how much? It will be 16. Ratna Sanupal, Vikas Yadav, Shivani has got option B as the answer. Yes, everyone else, please tell me what will be the answer for this question. Please be quick. What will be the answer? Be quick. Tell me. Yes, hurry up guys. Please tell me what will be the answer for this problem. Kalyan Venkatesh is saying B for this question. 2. Okay. So many students have given the right answer. Very good. Very good. You all have given the correct answer for this question. You know that discharge, it is a Froude model law. And we know that the Froude model law, discharge of prototype over discharge of the model is equal to Lp by Lm over 2.5. Or it is equal to 5 by 2 or 2 by 2.5. So it is very simple. The discharge of the prototype is given, that is 2048 divided by discharge of the model is equal to 16 over 2.5. Discharge of the model will be equal to 2048. 16 by 2.5 will be power 2.5 will be equal to 1024. Okay, that will give you 2. Clear? So the answer will be 2. Okay, you have sent me the mail, Muhammad Hafzal. I will definitely reply to your mail, don't worry. Okay, as soon as I will find time, I will reply to your mail. Okay. In a 1/36 scale model test of a spillway, discharge of the flow over the model is 6 meter cube per second. If the velocity of the flow over the model was found to be 5 knots, knot is also the unit of measuring the speed. Okay, especially for measuring the speed in for a basically of a spillway or in the ocean, we use the unit of knots. Okay, so 1 knot is equal to 0.5144 meter per second. They have given the value of 1 knot. So 1 knot is also the one of the unit of measuring the speed. So in this question they have given 1/36 model of a spillway. Spillway is given. And the discharge of the model is 6 meter cube per second. You have to find discharge of prototype. Hurry up, be quick. Be quick, guys. Yes, my dear students, be quick. Yes. Hurry up, my dear students. Hurry up, be quick. Okay, for the last question, many students have given the right answer. For this question, please tell me the answer quickly. Shivani has given option B for this question as the answer. Yes, hurry up, my dear students. Please be quick. Akhilesh has given option B. Vikas Yadav has given option B as the answer for this question. Okay. Please everyone be quick, my dear students. We have to really hurry up. Increase your speed. Yeah. So the answer will be option B for this problem. Again, it is a case of a spillway. A spillway comes under Froude model law. It comes under Froude's model law. And in Froude model law, we know that knot means knot is the unit of velocity. Knot is the unit of velocity. Okay, it is also used like we use mile as the unit of distance. Similarly, we use knot as also the unit of velocity. And 1 knot is equal to 0.5144 meter per second. So discharge of the prototype by discharge of model will be equal to length of prototype by length of model over 2.5. So my dear students, it is simply they have given the scale ratio. So LP by LM will be equal to 36. Discharge in the model is given 6. Okay. But in this case, you don't have to find that value of discharge. You have to find the value of velocity. Okay. The important thing is that you don't have to find the discharge. You have to find the velocity. So this is not important relation for you because you don't have to find the discharge. So what is the relation of velocity? Velocity of the prototype by velocity of the model is equal to LP by LM root. This is the relation of the velocity of the prototype by model in the case of Froude model law. Now my dear students, the velocity of the model is 5 knots. As you know, 1 knot is equal to this. So it will be 5 into 0.5144. You will be getting the velocity of the model. Okay. That will be giving you 2.572 meter per second. This is the velocity of the model. Now you can just simply put the values. You will be getting velocity of the prototype will be equal to 2.57 root of LP by LM. Root of LP by LM. What is LP here? LP by LM is 36. So this will be simply 6 into 2.57. That is 15.45. Are you getting the answer, everyone? 15.45. Next question, in a model test of a spillway, See, this question very comes in the exam very much, spillway. That is why I have also taken this question repeatedly. In model test of a spillway, the discharge and the velocity of the flow over the model were 2 meter cube per second and 1.5 meter per second. The discharge over the prototype, which is 36 times the model size, will be. You have to read the question very carefully. Here they have not given the scale ratio directly. They have given a statement of that. Instead of directly giving the scale ratio, they have given a statement. And the statement is the discharge over the prototype, which is 36 times the model size. That is, the size of the prototype is 36 times of size of model. This is the meaning of the statement. The discharge over the prototype, which is 36 times the model size. So LP by LM will be equal to what? 36. This will be the value of LP by LM. Clear? Now it is very simple question. You can easily solve the question. Hurry up. Tell me the answer. The discharge of the model is given 2 meter cube per second. This is the discharge of model. You have to find discharge of prototype. Hurry up. Be quick. Akhilesh has given option C. Dharani Krishna has given option C for this question. Yes, please be quick, my dear students. Please hurry up. Dinesh Kumar has given 2. 2 means Ratna Sanupal has given option C. Shivani Rai option C. So it is a very simple question. You just have to simply apply this. You will be getting the discharge of the prototype by discharge of the model will be equal to LP over LM over 2.5. This will be simply 36 over 2.5. The discharge of prototype will be equal to 2 into 36 over 2.5. We will be getting 15552 meter cube per second. Are you getting the answer, everyone? Yes. So now let us quickly solve the next question. A 1 by 10 spillway model has a discharge of 1.5 meter cube per second. If the flood phenomena takes, if there is a flood phenomena in the spillway, takes 15 hours to occur in the prototype, the time it will take in the model is, there is a model, there is a spillway. The spillway is having a discharge of, the model of the spillway is having discharge of 1.5 meter cube per second. If the flood phenomena in the model, in the prototype, if suppose in the spillway there is a basically problem of flood, and that flood phenomenon in the spillway is taking 15 hours to take place, then how much time it will take place in the model of the spillway for the flood to take place? Yes, hurry up. Again, we are having a spillway here. A spillway comes under Froude model law. It comes under Froude model law. And according to this, we know what is the relation of the time. Akhilesh has given option D for this question. Rishabh Yadav option C. Ratna Sanupal option C. Rajesh Prajapati option C. Yes, many of you are Vikas Yadav option C. Shivani option C. Yes, correct. As you know that time of prototype by time of model, according to Froude model law, is equal to root of LP by LM. LP by LM will be equal to what? LP by LM will be equal to 10 here. So this will be equal to root of 10. Discharge of the prototype, sorry, time in the prototype is equal to 15 hours by model. The time of the model will be equal to 15 by root of 10. This will give you 4.743 hours. Are you getting this value, everyone? Tell me. Is everybody getting this value? Yes? Very good. Very good. Excellent. You guys are doing excellent today. Very good. See, this topic is very, very important for numericals. There is a chance that question can come from this topic in the GATE exam. 100% chance. 100% chance are there that question will come from this topic. Okay? So if you become perfect in this topic, then you can secure your 2 marks for sure. Okay. Next question. A model of a submarine is scaled down to 1 by 25 of the prototype and is to be tested in a wind tunnel. The speed of the prototype at which we are to estimate the drag is 10 meters per second. The ratio of the drag between model and prototype is, see one more thing, this is the viscosity. Viscosity of the sea water is equal to 1.21. Kinematic viscosity of the sea water is 1.21 into 10 power minus 2 centimeters square per second. Viscosity in the air is equal to 1.64 into 10 power minus 1 centimeters square per second. The density of the sea water is equal to 1027. Density of the air is this. Now in this question you have to figure out two things. Which model will be applied? Reynolds model or Froude model. Second thing you have to figure out is what are the dimensions given for model prototype. Yes, hurry up. It is a very excellent question. It is excellent question actually. Very good question. So everyone quickly answer the question for this particular question. Please be quick. Please be quick, my dear students. Hurry up. Yes, Shivani is saying Reynolds model law will be applied. Okay. Reynolds. Rishabh is saying Reynolds. Okay. Because we are having a submarine and submarine comes under fully immersed body. Fully immersed body. And fully immersed body will be using the Reynolds model law. Very good. Excellent. You guys are doing excellent today. Very good. See, the way you guys are responding today, you are giving the answer. It is remarkable. It's good. Your preparation level makes me happy that you guys are having such a good preparation. Okay. Yes, come on, be quick. So apply the Reynolds model law and find the ratio of drag force. What is drag force? Now, because it is a Reynolds model law, you cannot apply the force relation that we have studied for Froude model law. We cannot use that relation because that is for Froude model law. So, you have to find the relation of drag force. What is drag force? Drag force is equal to half of CD into rho into A into V square. This is the formula for drag force. This is the formula for drag force. It is equal to half of CD is the coefficient of drag into density into area into velocity square. Because this is a constant, half is constant, CD is constant. So you can also say that drag force is also equal to, because these are constant, we can also say it is equal to rho into A. A has a dimension of L square into V square. So you can also write drag force as rho L square into V square. Because A has a dimension of L square. So we have to find the relation of drag force or ratio of drag force between model and prototype. So actually you have to find the drag force of model by drag force of prototype. So that will be equal to density of the model into ln by of model square into velocity of model square divided by density of the prototype into LP square into VP square. This you have to find. This you have to find in this question. Now the question is, what are the dimension of the model and prototype? They have not mentioned what is model here, what is prototype here. They are simply saying that we are having a submarine and that submarine is basically tested in a wind tunnel. It is tested in a wind tunnel. So that means wind tunnel, your model is tested. Now wind tunnel will be working in air. Wind tunnel works with air. The working fluid will be air here. And submarine will be tested in water. So working fluid will be sea water here. Because your submarine is the prototype and your wind tunnel is the model. Wind tunnel. That means whatever will be the dimension of the air, that will be dimension of the model. Dimension that is density of air is equal to density of the model actually, that is 1.34. Density of the sea water will be density of the prototype, that is 1027. Similarly, kinematic viscosity of the seawater will be, that is kinetic viscosity of seawater will be equal to viscosity of prototype, that is 1.21 into 10 power minus 2. Kinematic viscosity of air will be density model, for that will be for model, that will be 1 power minus 1. The drag force in the prototype, they have given that the prototype at which we are to estimate the drag is 10 meter per second. That means the speed of the prototype is given, speed of the velocity of the prototype is equal to 10 meter per second. Okay. Okay, once again, okay, again let me just clear you this. Because we are testing our submarine inside a wind tunnel, submarine works in seawater. So the value given for seawater will be the value of prototype. The values given for wind tunnel works with air. So values given for air will be the dimensions of model. Because your model is tested in a wind tunnel. Okay. Now wind tunnel works with what? It works with air. And submarine actually works in water, seawater. Okay, so the dimension of this will be dimension of prototype, and dimension of the air will be dimension of model. What is the speed of model? Oh my god, how can you find the speed of model? How can you find the speed of model? It is very difficult, my dear. How can you find it? We can do it. How? Let's see that. We know the Reynolds model laws can be applied here. So Reynolds model number of model will be Reynolds number of prototype. Reynolds number is equal to rho VL by mu. Okay, it is looping. Is it fine now? Please tell me. Is it fine? Is it fine now? Please tell me. Is the looping problem fine? Is it fine? Is it fine? Please tell me. Is it fine, everyone? Please tell me. Yes? Is it fine? Is it fine? The audio video fine now? Actually, there is an internet issue at my end. It has been raining from the last 2 days, and in the Noida side, I'm living in Noida right now, so it is basically it's raining from last 2 days. So maybe because of that, there's some problem, there's some technical glitch in the internet, and so that is why it is causing the problem. Okay. So how to find the velocity of the, because you have to find the ratio. Everything is given. Density of the model is given. Density of the prototype is given. Velocity viscosity is also given. Everything is given. Even the scale ratio is given 1/25. That means Lm by Lp is given in this question. Lm by Lp is also given 1/25. It is also given. What you require in this question is just the velocity of the model is required. That is not given. So how can you find the velocity of model? We can use this Reynolds model law. We know the Reynolds number of the model is equal to Reynolds number of prototype. But the problem here is they have not given the dynamic viscosity. They have given the kinematic viscosity. So we can also write it as VL by mu of model is equal to VL by mu of prototype. Because we know that the kinematic viscosity is equal to dynamic viscosity by density. So we can also write this Reynolds number in this form, right? This is also the way in which we can write the Reynolds number. So we can simply say that velocity of the model by length of the model will be equal to kinematic viscosity of the model. That will be velocity of the prototype into Lm LP divided by kinematic viscosity of the prototype. Because all these things have been given. Velocity of the model will be equal to velocity of the prototype, which is 10 into LP by LM into kinematic viscosity of model by kinematic viscosity of prototype. So that will be 10 into 25 into kinematic viscosity of model is equal to 1.64 into 10 power minus 1. And kinematic viscosity of the prototype is equal to 1.21 10 power minus 2. Okay, clear everyone? If you just put all the value, you will be getting the velocity of the model. How much is the velocity of model you are getting? Please tell me. What is the velocity of model? So you will be getting velocity of model as 3388.43. 3388.43 meter per second. You will be getting this value of the velocity of the model. Is it clear to everyone? Is it clear? Yes, are you able to get this, everyone? Yes, are you able to understand this thing? So we can find the velocity by using Reynolds number relation. Now we have got the relation of the velocity. We can simply say that drag force of model by drag force of prototype will be equal to density of the model into LM of the model square into VM square divided by density of the prototype into LP square into PP square. So you'll be getting the answer. Ratna Sarnupal has given the answer as 0.239. Are you getting the answer, everyone? Please tell me. That will be simply equal to density of the model is given as 1.34 into LM by LP. LP will be equal to 1 by 25 square into VM square is equal to 3388.43 square divided by 10 square, and this is divided by 1027. So if you just solve it, you will be getting this value 0.23. You will be getting the value as 0.239 or approximately 0.24. Are you getting this value 0.24 or 0.2396? Is everybody getting the answer or not? So this is a very good question that can come in the GATE exam. This question is very important. That can be asked in the exam. Okay? Clear everyone? Is it clear to everyone? So let us solve the last question of this session. The last question of this session, let us solve that. Clear? Let us solve the last question of this session. Oil of specific gravity 0.85 and viscosity 3 into 10 power minus 2 twice, flowing in a pipe of diameter 1.8 meter at the rate of 3800 liter per second. The tests were conducted in a 25 centimeter diameter pipe using water at 25 degrees Celsius. Find the velocity in the model. The water viscosity at 25 degrees Celsius is equal to 0.01 poise. Now, firstly, you have to understand which model will be applied. Reynolds model or Froude model. Then after that, you have to understand how we will be solving the problem. Now hurry up guys, be quick. Be quick guys, be quick, hurry up. Yes. Oil of specific gravity 0.85 and viscosity 3 into 10 power minus 2 twice, flowing in a pipe of diameter 1.8 meter at rate of 3800 liter per second. Yes, Reynolds model, because it is a flow of pipe, because it is a flow in a pipe, because flow in pipe is given, flow in a pipe is there. So Reynolds model law will be applied. Reynolds model law will be applied. Now since you have figured out that it is a Reynolds model, then you have to understand how to solve the problem, right? Now they have given this oil of specific gravity 0.85. So we are having one fluid is oil that is having a specific gravity as 0.85. That is density of the oil is 850 kg per meter cube. Having viscosity of this much, viscosity of the oil is 3 into 10 power minus 2 twice, or it is equal to 3 into 10 power minus 3 Pascal second. Okay, because we know that 1 poise is equal to 1 by 10 Pascal second. Next is the discharge is given. The diameter is also given. The diameter is given as 1.8 meter. One dimension is 1.8 meter. And discharge is also given. Discharge is 3800 liter per second. Or it is equal to 3.8 meter cube per second. Now, try to read the statement after this. The tests were conducted in a 25 centimeter pipe. Tests were conducted in a pipe. That means tests are conducted on what? Tests are conducted on a model. That means the model is having whatever data we have studied this written so far. This is for prototype. This is a prototype. The tests were conducted in a 25 centimeter pipe. That is, the diameter of the model is equal to 0.25 meter. Now in that pipe we are using water. So water will be having density of the model will be equal to what? 1000. Because in your model is using water and prototype is having oil. So this is what density of the oil or density of prototype. This is viscosity of the oil or viscosity of prototype. This is diameter of the prototype. Okay. Density of the model will be this, diameter is this, and viscosity is also equal to 0.01 poise. That is, viscosity of the model is 0.01 poise or 0.001 Pascal second. Clear everyone? Is it clear to everyone? So now my dear students, you have to listen it very carefully. You have to find the velocity in the model. You have to find the velocity in the model. How can we solve this problem? Because two things are missing here. They have not given the velocity of the prototype. Velocity of the prototype is also not given. But one thing is given. The discharge of the prototype is given. Discharge in the prototype is 3.8. The diameter of the prototype is given 1.8 meter. So basically, if you try to understand the question is like this. We are having a pipe having diameter of 1.8 meter. This is your prototype. This pipe is having oil. Oil is flowing here. And oil is flowing in this prototype, which is having density of 850 kg per meter cube. And we have a model. We have a very small model of that, which is having the diameter of 0.25 meter. The density in this model, we are having water. The density of the model will be equal to 1000. So in the model we are having water. Okay. So solve the question quickly. Hurry up. Be quick. Hurry up. It is a very simple question. The discharge of the prototype is given in the question. So discharge of the prototype is equal to area of the prototype into velocity of the prototype. Very good. Gaming. 3.8 is equal to area of the prototype will be pi by 4 into diameter of the prototype square into velocity of the prototype. By using this relation, you can easily find the value of velocity of the prototype, because diameter of the prototype is given in the question. You'll be getting the velocity of prototype. That will be velocity of the prototype will be getting as, by solving it, you will be getting the velocity of prototype. So that will be equal to 1.5 meter per second. Shivani Rai has got the answer 3.047. Ratan Sanupal 3.04. Yes. Tell me the answer quickly. Velocity of the model will be equal to what? They have asked the velocity of the model. Velocity of model will be 3.046 meter per second. This will be the answer. Okay. So we have got the velocity of the prototype. So you have to find velocity of the model. How can you find it? We'll be using the Reynolds model law. Reynolds number of model will be equal to Reynolds number of prototype. That is rho VL by mu of model will be equal to rho VL by mu of prototype. Because we are using a pipe here, Reynolds number will be rho VD by mu and rho VD by mu. This will be the Reynolds number formula. So now you can simply use the relation. This will be density of the model into velocity of the model into diameter of the model is equal to mu of the model is equal to density of the prototype into velocity of prototype into diameter of the prototype divided by. So everything is given in the question. You can just simply find the velocity of the model will be equal to density of the prototype divided by density of the model into dp by dm, diameter of prototype by model into Vp by Vm into mu m by mu p. Just put all the value. Density of the prototype is equal to 850 divided by 1000. Diameter of the prototype is equal to 1.8 divided by 0.25. Velocity of the prototype, oh sorry, you have to find the velocity of the model. You have to find it actually. Okay. This is given as this is 1.5 into mu m. What is the viscosity? That is 0.001, and of the model it is prototype is equal to 300 power minus 3. If you solve it, you'll be getting the answer. You'll be getting 3.06 meter per second. Are you getting the answer? Velocity of the model will come out to be 3.06. Is everyone getting the answer for this question correctly? Okay. So I hope you all have learned from this question. Today we have solved 4 to 5 questions from Froude model law and 2 questions from Reynolds model law. So in your exam, this topic is very, very important. There is 100% chance that question can come from this topic. Okay, that is a very, very important topic. Clear? Before we conclude the session, I would like to tell you about a paid course, Vision 2022. It is a paid course for GATE and ESE 2022 exam. If anyone of you is interested for preparing for GATE and ESE 2022, who are in the BTech second year and third year, then you can also take our Vision course, Vision 2022 paid course. Okay. In this paid course, we'll be covering the entire syllabus of ESE and GATE 2022. This is the list of the toppers who have got selected in the GATE exam and ESE exam. And 60 plus Gradeup students have got selected in the top 100 in the 2020 exam. One more thing, if you have not heard about Gradeup Super gives you access to all our paid courses, okay, and also to Gradeup Green Card. So just with one Gradeup Super, you can get access to all our paid courses and also to Gradeup Green Card. With Gradeup Super, you will be able to access all our paid courses of 3 months, 12 months, 18 months, or 24 months. Which are having these costs. Depending on what course you want to study, you can just take one Gradeup Super and you can study from any of the courses. So that is all for today's session. Tomorrow topic is boundary layer. Okay, this topic we are going to understand tomorrow. Thank you so much for joining me for today's session. Today our lecture is also completed on time because already we are basically, this is the perfect time to complete the lecture. It should not extend much, okay? Because if you will not sleep early, you will not get up early. You have to study also, right? So I think this is the perfect time for completion of the lecture. Tomorrow we also will try to complete the session by 12:30 maximum. Okay. So thank you so much for joining me for today's session. And this was all in the topic of Reynolds model law and Froude model law. So I hope you all have understood this topic and you have learned a lot from this topic. So thank you so much for joining me and have a very good day. I'm going to see you tomorrow at 11 p.m. for the topic of boundary layer theory. Thank you so much and have a very good day. Thank you everyone. Good night everyone. One more thing, if you have liked the session, then also please, if you have not yet liked the session, then please like it also, share it also, and do subscribe our channel and press the bell icon. Thank you everyone. Good night.